Hi guys, I hope it's going well. We're on to lesson 2 of our last unit here. I think this topic is maybe one of the most interesting topics to do in the whole year, and it connects a bunch of different things, and it's really will be really important for your stats class when you're in first year university or second year university. So just a few things to go through before we get to what we're going to talk about, which is the normal distribution and z-scores. So remember we learned about measures of central tendency, and that's really just referring to the average. So the average is the mean. It could be the median, which is the number that falls sequentially in the middle, and or the mode, which is the one that repeats itself most often. And then another thing that's related to those things, if you want to talk about variance or how much data is away from the mean, we talk about standard deviation. And we use this sigma symbol there for standard deviation, and it takes each data point x and subtracts the mean from it and then squares it and divides by the total number of points. You're not necessarily going to use this formula a lot, but it's just good to remind ourselves. So standard deviation is just, remember, a measure of the amount of variation in the data. In a set of data away from the mean. Another way to think of it is just it's the measure of spread of the data. So if your data is clustered more around the mean, then you're going to have a smaller standard deviation. If it's spread out more, you're going to have a larger standard deviation. So if we take a look at this example here, I took 600 students from that Census at School website that we were using, and I graphed all of the heights of students in high school. And so what you see is this tendency that falls into what is called the normal curve. So this curve, the red line, is the normal curve or normal distribution. What's interesting about the normal distribution is that it's symmetrical about the middle, and the middle is where the mean is equal to the median and the mode. And so the normal distribution we're going to talk about for several classes, but there's a whole bunch of things that make it interesting. One, all of the data that falls under this red line, it contains the probability of finding data at various points on this curve. And so the area of the curve equals the amount of data underneath the curve. And so there are lots of natural phenomena that fit this thing that's just called the normal distribution. Another name for it is the bell curve. And for example, obviously here we put height, but a lot of naturally occurring things about us or about nature fit here, like the distribution of IQ scores for people, or things like physiological things like blood pressure. The blood pressure of people fits here, where the average blood pressure would be in the middle, somewhere, whatever that average blood pressure is. Other things like if you're manufacturing things, the size of what you make, it's never going to be exactly the same. And so the distribution of sizes for many things in manufacturing also fit into a normal curve or a normal distribution. And so manufacturing deviations, I'll say. And so what's so interesting or special about the normal distribution is that sets of data that fit the normal distribution can be defined or described completely by the mean and the standard deviation. And that we're going to expand on that idea, but let's just write that down. So sets of data that fit the normal distribution. So not everything does, but a lot of things do. can be described by the mean and standard deviation. Remember, the mean is x bar and standard deviation we just talked about, which is sigma. And so what we're going to see is the probability of values on the normal curve can be easily calculated. So again, as long as you know the mean and the standard deviation, you can figure things out. And so if we label this, and we're going to learn more about this next class as well, but so the middle is our mean. Basically, you can go up here. Let's say I go somewhere like here. This would be the mean plus 1 standard deviation. And so data that fits this, I can describe, if I know what that data is and what the values are, 1 standard deviation above the mean, I know how many data points are going to be there, and I'll also know what the value is. And you can continue, and so the distribution is very predictable. So this would be the mean plus 2 standard deviations. And then over here you would have very few points, but it would be 3 standard deviations. And then we can do the same thing below, where we subtract a standard deviation and subtract 2 standard deviations. And we'll get into how many points are going to fall above and below those types of things. And I want to kind of give some examples here as we go through. So basketball fans from 10 years ago might remember this guy here. So I just want to show how you can see that not a lot of people are going to fit, or a lot of data points are going to fit in certain areas of the curve. This guy here, and if we were in class, I'm sure somebody would shout it out, but this is Yao Ming. And Yao Ming is about 7'6" or 231 centimeters. On the distribution of the normal curve, that would put him way over here. So this is Yao Ming. So he's this basketball player, Chinese-American basketball player, was very good. He was also one of the tallest players ever to play. And so on this normal distribution, once I get all the way over to where Yao is, there are almost no people in the world who are that tall. And the reason is because if you correspond to this curve, there's almost nothing underneath that point. There's no area underneath that curve. So he is probably many standard deviations, maybe 4 standard deviations above the average height, above the mean. The tallest man, just in case you were wondering, is this guy. I forget his name. This is from 1940, but he didn't live too long, but he was almost 9 feet tall. It's believed he was 9 feet tall. So you can kind of just see where you might be. This is high school students, but I know we've got some people way over here who are well above the average height on that normal curve. Other things like the IQ. So again, here's my mean in the IQ. So the average IQ is about 100. And Stephen Hawking has an IQ, or had an IQ, I should say, of 160. And so that puts him at 4 standard deviations above the mean. So once you get to that level, there's very few that are going to fall in that range. But you can also think, if you are average, that means here you are the 50th percentile. And so remember, percentiles just indicate how many things are below you. And so if you're the 50th percentile, you've got 50% below, and in fact, you have 50% above as well. So that's the beginning of the normal curve, and we're going to talk more about it as we go through. So here's some other properties, and I kind of mentioned most of them here. but you can go through it if you want. So in order to use the normal distribution, what we're going to do is use what's called this Z-score table. So this is the Z-score table. And what that thing does, you may remember from before, the numbers on the left corners, so this Z and this Z, indicate the percentiles, or the number of standard deviations rather, above or below. So this is our negative if I'm below the mean, and these are my positive if I'm above the mean. So this would indicate, let's say this one here, that I'm 3 standard deviations below the mean. And if you use that, let's say it's exactly 3. So I would go over, and we're going to try this in a second, but that means that I am really low. So I'm at a percentile of 0.0013, which would correspond with 0.13%. So that means very few things would be below that. So let's just try using this table. So it says, what is the percentile for the following Z-scores, and sketch their distributions. So this is my Z-score. What that means, again, is that I am 1.25 standard deviations below the mean. So before we actually use the table, let's just imagine where that might be. So let's say it's somewhere here. And we're just doing this just so you have a visual, and we'll get more accurate later on. But what that means, what I'm going to find in my percentile is all of the numbers that are below basically here. And that's what a percentile is going to tell me. So this might be minus 1.25 below the mean. So if I take the mean minus that, let me just fix that up. So the mean minus that many standard deviations below the mean. And so that gives me there. So if we want to try to figure this out, so let's go to our table. So I'm going to enlarge it, and I'll give you a larger table so you can see better later. So if I'm minus 1.25, I'm in the negative section over here. So I go to minus 1.2, so that's here. And then I got to scroll over so I get to 0.05. So that would be minus 1.205. So if I do that, this is my percentile. So my percentile that matches up with that is 0.1056. So let's just write that down. So a Z-score of minus 1.25 corresponds with a percentile of 0.1056. So therefore, approximately 10.56% are below that value. And that's what a percentile tells you. And so knowing if something fits a normal distribution, you can figure out these percentages or percentiles. And we'll talk about how that relates to probability. So this one, we've got a Z-score here of 2.35. So if we go up to our table, so now we're in positives. So I've got 2.3, and then again, we're at 0.05. And so that corresponds to, it looks like 0.9906. So if I'm 2.35 standard deviations above the mean, it means that I've got a percentile, of 0.9906, which is the 99th percentile. So you can see it doesn't take long to go, or far to go above the mean. We're only just over 2 standard deviations above the mean that I reach this high percentile. So what that means is that you're probably somewhere over here. So this would be like the mean plus 2 standard deviations. And so what you've got is 99% of all of the data is below you. So it would be all of this. Conversely, this would mean that there's only 1% approximately above. And so visually, I think that's helpful to see because we're going to talk about these various situations. Okay, so let's try a question here. And so this one, it says we've got the annual returns from a particular mutual fund are believed to be normally distributed. So Erin's considering investing in this mutual fund. She obtained a sample of 20 years of historic returns, which are listed in this table. So it says determine the mean and standard deviation. So what you would do on your calculator is you would want to input all of the return percentages. And so you would go to data and edit your list and put that in. So if you do that, and I'm going to give you the numbers, you type them all in. So this is the return percentage we're looking at. We get a mean of approximately 12.1% return in the 20 years of data. And we get a standard deviation from that. And again, if you do one variable statistics, you'll get all this information off of your calculator. You get 9.3756. And so there's my mean and standard deviation. So it says, assuming the data are normally distributed, what is the z-score for return of 9%? So remember a z-score we can calculate by doing the data point minus the mean divided by the standard deviation. And so in this case, my x is going to be 9%. My mean, which we figured out to be 12.1, that's my x bar, and my standard deviation is 9.3756. So if I put that in, my z-score is going to tell me how many standard deviations I am away from the mean. So if I punch that in, I get minus 0.33. So that gives me a standard or a z-score of negative 0.33. And so that's what they've asked here, is just that. So remember, and it's really essential to understand this, this is the number of standard deviations below the mean because it's negative. It's really important, that concept, to understand. So the next part, which is to incorporate probability. So it says determine the probability that the annual return will be less than 9%. So in order to figure this out, what we need is just the percentile. The percentile tells us the percentage below that value. And notice here it says less than 9%. So if I go to my z-score table, so I'm going to go up, and we want to use the z-score of negative 0.33. So if I do that, so negative 0.33, so there's negative 0.3, and there's my value for negative 0.33, which is 0.3707. So I get a percentile, I believe I said 0.3707. So that's the number of data that are below 9%. So therefore, we can change it if we want to percentages. The probability that the annual return will be less than that is just 37.07% chance of a return below 9%. And if you think of it, that makes sense because 9% is below the average. The average was 12.1. And assuming 50% of the time, if you're at the average then, because we were normal curve. And so if you imagined it visually, if this is my normal curve, what we've got is something maybe around here. So my mean is there. So this would be my 9%, something like that. So the next one says, determine the probability that the annual return will be at least, so at least 9%. So in order to figure that out, what we want this time, and I'll just change colors, so at least 9% means I want everything on the other side of that. So we've already figured out there's this 37.07% chance of return below, so all I have to do is take 100 minus that, and that's going to give me the percent chance above that. So therefore, there is a 62.93% chance of a return of at least 9%. So the next one, kind of similar. It says determine the probability that the return will be a negative percentage. So a negative percentage meaning that you've lost money. So if we want to, we can think of the X value being at 0%. So I'm going to take that and use my Z-score table. So my Z-score, again, X minus the mean divided by the standard deviation. So I plug that in and I get a negative 1.29 Z-score. So that means I'm 1.29 standard deviations below the mean. So if I look at my table, so I'm going to just write table. If I go back up, I'm kind of ruining my table, that's okay. Minus 1.29. So if I do that, that's here, which I believe is 0.0985. 0.0985. So therefore, the probability is 0.0985 or 9.85%. So very small probability that you'll get a negative percentage. And then the next one's kind of a logic thing. It says, how many years out of the next 10 should Aaron expect to have returns greater than 6%? So again, we have to start with our Z-score, where X is 6. Plug in our mean and our standard deviation. And we get, again, a negative number, 0.6506. So if you go to the table, and I'm just going to assume, I would press pause and see if you can find this one. This corresponds to 0.2578. So what we want is the expectation that she gets greater than this. So we want the complement to this guy. So I want to do 1 minus that, which gives me 0.7422. So that's the probability that she's going to get 1 year something greater than 6%. And so in 10 years, how many times would we expect? So this is basically 3/4 of the time we would expect to get greater than 6%. So remember an expected value. The expected value here, you take the number that we're talking about, so 10 times the probability that it's going to occur. So 10 is the years, and the probability here, which is going to be 0.7422. So that just works out to 7.422 years. So we would expect that we'd get returns greater than 6%, 7.5 out of 10 years. And so lots of things you can do on this, and we will continue next class, but let me know if you have any questions. Try these ones out. You'll have to use your calculator